2.5 Admins, episode 240. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, your customary plug, Alan, is core infrastructure, why you need to control your NTP.
Yeah, so in this article, we talk about the advantages of running your own network time server instead of letting every device on your network just do whatever it wants to do, especially with more and more IoT devices that don't have their own real-time clock and depend on NTP to know what time it is just in general. So they're kind of querying NTP on a really frequent basis, and you can control a lot of the traffic on your network by locking that down.
Right, well, link in the show notes as usual. Something we were talking about off-air recently was the difference between testing latency and throughput, and I thought it might be interesting to talk about it on air.
Whether you're talking about network stuff or storage stuff, you name it, humans really intuitively, we keep coming back to throughput being the metric that everybody wants to rush to. Even if you go to the dreaded car analogy, the first question usually about a car is, how fast does it go? And the answer is going to be in miles or kilometers per hour. And that doesn't really address most of the problems that we actually have with the same devices that we tend to like to measure by their top throughput. If you replace your Prius with a Lamborghini, you're probably not going to get to work any faster because you probably weren't bottlenecking on your top end speed, going as fast as you possibly could, flooring it down a straight edge, stretch of the interstate. You're probably bottlenecking on waiting at traffic lights in between your house and work. So if you actually wanted to get to work faster, you probably should be looking for, like a scooter or an e-bike, not a Lamborghini.
Yeah, and to bring it back to topics that we should be talking about, getting a Wi-Fi 6 access point is not necessarily going to give you a better experience than a Wi-Fi 5 one. The top theoretical speed and throughput will be better, but there's more to it than that.
There is more to it than that, but the complicated thing is that Wi-Fi 6 router and Wi-Fi 6 NIC might actually give you a better experience than the Wi-Fi 5, even if it claims a lower top-end throughput, because there are actually improvements in the Wi-Fi 6 protocol in 802.11ax over 802.11ac, which was Wi-Fi 5. Now, unfortunately, a lot of those improvements haven't really proved out in the real world the way that we were hoping that they would, but there are specifically a lot of changes in the protocol that are intended to solve off some of those actual rough spots where having a high top-end throughput doesn't really fix it because your problem actually turns out to be congestion when more than one person needs to use the same channel at the same time, and you don't have an efficient, effective, and fair way to split the time. There are changes in the newer protocols that are intended to address that, and in some cases they work well, and in some others they don't. But your larger point that you can't just go, oh, wow, this one says, 10,000 megabits or, whatever, that it must be better. No, that doesn't mean anything. The number on the box is a lie.
I suppose a better analogy might be gigabit Ethernet in a laptop versus a faster wireless card, but you're going to have a way better time on a video call with that slower, in quotes, Ethernet than with the wireless.
Correct, because although your theoretical maximum throughput is considerably lower on the gigabit wired card than it is on most modern Wi-Fi cards, well, Wi-Fi in particular, you usually can't actually achieve anything close to the rate that they're claiming because it's a transmission rate. It's not a real world data rate. You're talking about like a modulation rate a lot of the time. It's just everything is a lie when it comes to those speed ratings that you see on the box of a Wi-Fi device. But the metric that you're really getting out of that wired card that makes the video call go so much better is you have lower latency per packet for one thing, and even more importantly, you have extremely predictable latency because the wired network that your wired interface is speaking to actually has flow control and can manage multiple streams at once, full duplex, without them interfering directly with one another. So you have very, very predictable latency. It's the same on every packet. Whereas with the Wi-Fi, it's a best effort service and you have congestion issues, you have interference issues. There are any number of reasons that one packet might be drastically slower than another. And any one packet that is super slow just created an issue for the entire stream because they all need to arrive and be reassembled in order. There's only so much rearranging you can do because you can buffer a little bit of it to try to reassemble packets if they arrive out of order, but not much, because if you buffer more than a few milliseconds worth, well, then the delay is going to be obvious, and that's not going to work for real-time communication either.
Yeah, and obviously one of the starkest examples to this is hard drives. If you're trying to copy one big video file off a hard drive, you can do that at 200, 250 megabytes per second, and it'll go really fast and it'll be great. If you try to copy 10 different videos at the same time, the disk is going to spend all of its time waiting for the platter to turn and come around to the data it's trying to get, and the latency of each of those reads is going to go really, really high because it takes an average of 4 milliseconds to reposition the head, and so you can only do that on average 250 times a second. And so if each of those 250 reads you do is 4 kilobytes, then you're only going to be getting not even megabytes per second in the end. Whereas if each of those reads you're doing is a megabyte, then you're getting 250 megabytes per second. And so the latency can make a big difference there. And the latency isn't necessarily caused by the same thing every time. Sometimes it's physically moving something in the device. Or, like Jim talked about with the internet, if you lose one packet in the middle of a stream, you can accept a couple more packets beyond that. But in general, also to prevent attacks where you exhaust all the memory of a device, they'll eventually stop and say, don't send me any more until you actually resend the missing piece so that I can put all this back together and stop using up all my RAM buffering packets when I need to get these in order. And you can get this whole thing of like head of line blocking, where if you need all 4 pieces for something to work and you have 3 of the pieces, it doesn't matter that you have the next 100 pieces. You still need that 4th original piece before you can do the next thing, right? When you have these dependencies between the messages or the file or whatever, you can't do anything until you get all of those pieces to even know what the next thing to do is. And it really makes a big difference. And that's why often, when optimizing a website, if you're trying to make your WordPress page load faster or whatever, one of the most important metrics isn't how many megabytes per second somebody can download the image on your website. It is time to first byte. How big is the latency between when I ask for the picture and when I get the first byte of the picture? After that, it doesn't matter so much how fast the picture loads. It's probably not going to be the thing that affects the user experience. The biggest thing is how long it takes before they start getting anything. The time they're sitting there tapping their foot, waiting, and absolutely nothing is happening. If you look at some of the older tools for analyzing the speed of a website, they were called the waterfall display, because it's kind of like the waterfall paradigm for developing a computer program or whatever. We can't do this step until we've done the previous step, until we've done the previous step. And so it kind of flows down this way, like a waterfall. And for most things you do on a computer, it's the same thing. Whether that's, you can't load the pictures for the website until you've loaded the HTML, because you don't know what pictures are on the page until you load the HTML. But you can't draw the HTML until you know how big that picture is. And so you have to load the picture before you do the next thing, and so on, or the CSS and things like that. Or in a file system, if you go to look up a file, if all you have is the file name, you first have to figure out, okay, where's that directory? What's that file? What's the INO number of that file? And then actually open it and read it. So even before you can start reading the file system has to read some metadata and find out where on the hard drive is that file. And you get that same head of line blocking, where it doesn't matter how fast we can read the file. We first have to do these other operations to just find out, does the file exist? And where on the disk is the file? And then we have to reposition the head on the hard drive to where that file is. And all of these things add up to the latency and could mean, sure, we can send the file to you really fast, but if we make you wait a week before you get it, you're not going to be happy with it. And this came up especially with Amazon's Glacier backup system when they first rolled that out. And it's like, yeah, you can upload all your data to us and we'll store it really cheaply. But if you ever want to restore from backup, you enter a request and we'll email you somewhere between 6 and 24 hours later when you're able to start reading the data. So suddenly you have this ridiculous latency.
Another thing to keep in mind is that latency and throughput are usually mortal enemies. If we go back to Alan's example of the hard drive that's capable of producing 250 megabytes per second maximum throughput, but needs 4 milliseconds to do a head seek. Well, if you're actually doing a workload that's giving you 250 megabytes per second, you know that if you need a little bit of data really quickly right now, you won't get it because you don't have any headroom left in your IOPS. You are already pulling as many operations and as much data off the drive as you can, and it's going to take a little while to chew through however many operations you already have buffered to get you that maximum throughput before you can insert in this little tiny request for this little bit of metadata or this one tiny file here. Maybe it's just an image that lives in an icon on your desktop. So, you boot your computer and there's a whole lot of things going on and you see broken imaged icons on your desktop, or you've got a lot of latency. You want to click your launcher and, have a start menu or something pop up and it's really laggy doing it right now. Well, now you have some idea why, because when the drive is already really busy providing all this top-end throughput, there's no overhead left, for IOPS for these little itty bitty operations, and you see the latency. But this is the other reason I like to harp on latency. The thing that actually pisses you off isn't the throughput number going down, it's the latency number going up. If your big thing that you're doing, that you're copying a big file at 250 megabytes a second goes down to like 220 megabytes per second, that's not usually like the biggest deal. Like, you might be mildly annoyed if you see the number because you're like, that's not the big number that I like that makes me feel good, but it's not really messing with your day. On the other hand, if you go to click your launcher button and it takes, 3,000 milliseconds for the menu to pop out, you're ready to chuck your machine through the window. And that's that increased latency. That's the thing that really upsets you. But again, if you're satisfying the latency, you can't really get the top end throughput because you have a whole bunch of very small operations that are eating up all of your IOPS. But if you've got a high throughput operation, so either way, you're talking about one is kind of the enemy of the other, and you've got to decide which one is important to me. For most folks, they don't realize it, but the answer is latency.
That's especially one that can make a difference. And if you're using buffering in order to try to smooth things out, generally with hard drives, because the latency can be so high, we queue up multiple different commands we want at once, and the hard drive will try to sort them and do the one that's going to have the lowest latency first, right? If you're waiting for the disk to come around, if there's something that's going to come around sooner, we should do it first because then we'll have lower latency. We can get the most throughput from a hard drive if we give it all the work we want it to do and let it sort it out. But that does mean that if a couple of milliseconds later, we decide, there's this other thing that we'd like to do, and maybe it's actually more important, right? If you're copying a file in the background and trying to do something else, you probably want the something else to be able to kind of happen first, even if it slows down the file copy a little bit. But if you get put at the back of a very long line, then even if you're important, you're not going to get a good service time. You're going to have to wait until all the commands in front of you are completed before you can do the next thing. And so in order to keep the latency low, we have to keep the buffer small. But if we keep the buffer small, we don't get as much throughput as we could, right? It's the same thing with what we call buffer bloat on the internet, right? If your router buffers more, it can give you more throughput, but as the buffer gets bigger, your latency gets worse. And that can actually mean you can't get the good throughput, especially when you're doing too many different things at once. And so it's always a trade-off. You can trade higher latency for more throughput, or you can have better latency, but your throughput's going to be worse. These two things are constantly in tension, and usually it's one or the other that's limiting them. And this especially happens on the internet, where the latency is limited by, the speed of light in fiber or the speed of data going across copper. It's not really possible to get to Europe and back in less than 100 milliseconds from North America. And so knowing that, other than making a bigger and bigger buffer, there's no way to actually saturate a really fast internet connection from something that's that far away, other than having either a really big buffer or multiple separate flows happening at the same time. And this is why having multi-threaded workloads or downloading multiple parts of something at the same time can be a lot faster, because while the latency is always going to be 100 milliseconds, if I make 5 requests in the same second, the total latency is still only going to be that 100 milliseconds, but I'm going to get 5 times as much back in response to it.
This is also why it's important to keep your database server close to your web server, your application server, because what we're talking about, this 100 millisecond nominal latency to get back and forth from the Americas to Europe, that's one thing when you're talking about 100 milliseconds added on to the latency to fetch a web page a web page 100 milliseconds one time. But when that web page itself, in order to render it, it requires several hundred queries to be executed on a database server. Now you really want the application server to be doing the DB queries rather than you doing it. So instead of you having to execute 100 DB queries, each with 100 milliseconds latency, the application server, which is, probably got more like nanosecond latency, can chew through them all at once and then feed you the result with only the 100 millisecond latency added to the entire application.
Yeah, and if it can do a bunch of those queries all at the same time, that can ameliorate the latency. But at the same time, if it can't do the 10th database query until it knows the answer to the 3rd database query, then that can increase the latency, right? If we need the answer from one of the queries in order to even write the query for a later one, then the latency of the second one doesn't matter how fast it is. It matters how long it had to wait before we could even start counting against its latency.
One of my favorite examples, and I'm going to go right back to the car analogies everybody hates because I'm an old, but one of my favorite examples of the difference between throughput and latency and why it can matter, say, I don't care what networking technology you're talking about. You can be talking about, old school token ring Ethernet. You could be talking about fast Ethernet. You could be talking about gigabit. You could be talking about 40 gigabit Mellanox. You're still not talking about really high throughput. If you want to talk about super high throughput, that's a cargo van that's packed full to the roof with tapes that you drive from South Carolina to California. You can't beat that throughput. When it gets there with its terabytes or petabytes of data, then, that amount of data divided by the amount of time it took you to get there is an enormous number of throughput. But the latency sucks because it took you a week to get there. Obviously, there are cases when you don't have a week to wait for your data, so it might be more important to have the much lower throughput, but also much lower latency.
Yeah, that is a good analogy. But even to be a more basic car analogy, there's, like you said, the top speed of the car, but there's also like the 0 to 60 time, how long it takes to get off the stoplight and get up to that speed. And, it doesn't matter that your car can do 200 miles an hour if the electric car can get from 0 to 50, which is the most you can be doing on the street, a lot faster than you. And you spend most of your time waiting at stoplights and then have to accelerate off the stoplight.
Okay, this episode is sponsored by SysCloud. Companies big and small rely a lot on SaaS applications to run their businesses. But what happens when critical SaaS data is lost due to human errors, accidental deletions, or ransomware attacks? That's where SysCloud comes in. It's a single pane of glass to back up all critical SaaS applications, such as Microsoft 365, Google Workspace, Salesforce, Slack, HubSpot, QuickBooks Online, to name a few. SysCloud also helps with ransomware recovery, identifies compliance gaps in your SaaS data, monitors for unusual data activity, and can automatically archive inactive SaaS data to save on storage costs. Plus, it's SOC 2 certified, so data remains secure in the cloud. Over 2,000 IT admins already trust SysCloud to protect their SaaS data. Head to syscloud.com for a 30-day free trial, and for a limited time, use code 25admins to get 50% off your first purchase. That's syscloud.com. Let's do some feedback then. David writes, if tomorrow you had to quit your day jobs and take a profession outside of the IT industry, something like welding, landscaping, plumbing, or housekeeping, what tech would you definitely keep for your home lab? And what would you definitely purge? You're allowed to run it for yourself, you can share it with family and friends, but you're not allowed to charge people for access or for your time.
That's an easy one. I'm not getting rid of anything. I had all this stuff for me first. Figuring out a way to make money with it came later. So yeah, there's nothing I'm really looking to unload, honestly. I mean, you could make a case that the backup server doesn't need as many drives, but I'm going to sell them off? No, I'll just have a little bit more space than I need for a while until I outgrow that too, and we have to add more drives again.
Yeah, my home lab is mostly the stuff I want. So not just for me, but for my family, the Plex is a critical service to the point where I'm considering moving that to its own machine or something just because I need to be able to have downtime on the rest of my home lab when I want to update stuff and so on. But yeah, there's nothing in my home lab that I sell as a service or anything. So I don't think my home lab would change much. It might not be quite as big. And some of the machines that are adjacent to my home lab that are just backups and so on wouldn't necessarily be at my house anymore. But Yeah, I don't think I would change very much.
If it's currently in your home, it qualifies as home lab for the purposes of this question, Alan.
Yes, okay.
Yeah, what about the data center in your basement?
Mr. I don't have a home lab.
I didn't say I don't have a home lab. I'm saying that 3 of the machines in that rack are my home lab. The rest of those machines are somebody's production co-located in my home lab. Or backup, not production. But yeah, so there would probably be 100 terabytes instead of 700 terabytes in my basement. But other than that, I don't think there'd be much of a difference.
Yeah, and I would just have the same stuff as well. I'd still have a massive stack of laptops and various backup servers and everything because I like playing with this stuff. That's why I got into talking about it for a living, because it's just fun for me. I think that's a big reason why a lot of people get into this.
I mean, I guess I could do away with the, I've got a cardboard box in the floor of my upstairs office with 30 HDMI cables and 30 DVI cables in it. I guess I could get rid of that stuff.
I don't know. My box of random cables is definitely the homiest part of my home lab.
we didn't say anything about box of random cables. I'm saying I've got a cardboard box with 30 new in their own individual packaging unopened HDMI cables and DVI cables.
Right.
And the DVI cables are the ones that are kind of hard to come across.
Nowadays, yeah.
You wouldn't get rid of them all, though. You'd leave a couple.
Let's be honest. I probably wouldn't get rid of any because, you know, come on.
Exactly.
I think we've already established that 3 of us are A, not posers, and B, possibly hoarders.
I am definitely.
Definitely a data hoarder, but it really leads into also like just IT hoarding.
I struggle with that a lot. I try really hard to purge stuff and to, keep a lid on the amount of IT hoarding, but it's difficult because it does feel like every time you finally give up and like you throw out a drawer full of like weird cable nonsense things you've had for like 10 years, next week you need one of those cables and you have to buy one off Amazon.
Yeah, although I really do need to get rid of the Core 2 quads in my basement.
For me, a lot of it has come down more to organizing the hoard, really. I have almost nothing like that's a true junk drawer anymore, Like I have these these Tupperware kind of construction, almost like little baby Chester drawers that are stackable, and I'll put labels on them. Like I've got a drawer that's like nothing but power cords and power strips. I've got another one that's nothing but video cables. I've got probably the closest thing to a junk drawer is the one that's labeled, and this is exactly what it's labeled, USB/weird stuff. And that'll be everything from, those weird like USB-B cables that like used to come with inkjet printers back in the day to, the USB dongle things that would like hang off the back of UPSs, just whatever weird random nonsense like that would go in that drawer.
Yeah, like RJ11 to USB.
Yeah.
Yeah, so I have an actual like tool chest thing that was meant to hold tools. But yeah, the top drawer of that is all bits and bobs like smaller than my hand. It's all like the different like Molex to SATA power connectors, whatever little thing like that I need. The next drawer is all just hot swap trays for super micro machines. I might not need quite so many of those if it was just my home lab.
And do you still use a lot of Molex to SATA converters, Alan?
Occasionally I do still need those, yes. When you put a lot of hard drives in a machine, the power supply usually doesn't have that many SATA power connectors.
I just don't trust those Molex to SATA converters to not catch fire, man.
Yeah.
I think the more interesting part of David's question is like, which profession would you pick?
At first, I misread the question. I was thinking the same thing. And I was like, okay, do I have to pick something I'm sure I can make a living at? Or like, am I 7 all over again? And I'm just like picking what I want to do. Because if it's the latter, right now I'm going to be a motorcycle courier. Completely impractical, but if it's what I want to fucking do, there we go. How about you, Alan?
Yeah, I was thinking like, I've done a bit of welding, but no, that they don't really get joy out of that.
Teaching, I reckon you'd go into.
Yeah, that's what I've done in the past too. And yeah, as long as I didn't have to just teach the same thing over and over and over again, that's probably where I would go to, yeah.
That is the job, teaching though, isn't it? Same thing over and over again.
Right, but I don't want to teach the same TCP IP course over and over again. Although TCP IP I didn't mind so much. I don't know. Yeah, as long as I had a class that had at least a couple of people that were interested, then yeah.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Tom writes, my first backup is to a TrueNAS machine, and my second backup is to one of 2 encrypted external drives. I keep one at my father's house, and we exchange the drives whenever we visit. Last time driving home, I wondered whether the data on those drives is free of bitrot. I use an rsync script to copy the files to the drives, but I'm not sure that it will detect issues in files that haven't been modified. Is there an easy way to check the data that's on the drive now for correctness, or is it easier to just wipe them and start from scratch? Now, I'm just going to make a prediction here. You're going to say wipe it and do it again with ZFS.
No, we actually don't want Tom to use ZFS for those drives because Tom is doing a proper 3-2-1, and on his third backup, he's using a different file system, which protects him from potential bugs that might cause data corruption in ZFS itself. That's a good thing. I can't afford to do that because I've got too much data to back up too frequently, but if Tom can, Tom should continue to. So, in order to address Tom's actual question, how do I make sure I'm not suffering from bit rot on these things, since there's no simple, easy ZFS, zpool scrub to do it, what you would do is, if you want to check it in place, you can using rsync. Just run rsync with no algorithms, look down the list of arguments, you'll see -- checksum will force it to actually checksum every single file, rather than using the shortcut of saying, well, if the modification time hasn't changed and the size hasn't changed, then the file hasn't changed and I can ignore it. Now, you can do that. What it will require is you reading every single block of every single file on both the source and the target, which is probably not worth it. If you trust your source, you can more rapidly do what you want by, like you said, just blowing away the drive and running a clean rsync from scratch again. That will make sure that if you did have any bit rot, it's gone. This again assumes that you're starting from ZFS, and because it's ZFS and you have checksums on ZFS with live checksum checking and scrubbing periodically, you're very confident of the integrity of those files. If that's the case, that's going to be the easiest thing to do is blow away the drive and just replace everything. But like I said, if you really, really want to do an in-place audit, rsync with checksums. Now, if you want to add another layer on top of all that that might be a little bit more convenient and like a reasonable, look into a tool called Parchive. Parchive will preemptively check some files on non-checksumming file systems, save them as a very small companion file, and that way, even in the absence of ZFS checksums, you've got a checksum for the whole file. You don't have to grovel over everything to see, does this file match its checksum? You can just run Parchive, and it will rapidly do that for you without needing to involve the source.
I expect running rsync with the --checksum option will take approximately exactly the same amount of time as making the fresh backup. And so to Jim's point, you might as well be writing the data fresh because it will take probably the same amount of time or actually slightly less.
--checksum will take longer, period, because it's going to experience more fragmentation. It's going to need to do more stats. And also it's got a bottleneck on both source and target. So
right. And it's single threaded. So the checksum might actually start to impact the performance.
Right. And again, keep in mind, you have to read every single block of every single unchanged file from the source as well as the target.
But the only downside to just doing the backup fresh is it never tells you whether your old backup was good or not. And that's where maybe Parchive would be better to have a way to check. Or, if you run rsync with the checksum mode, at the end, it will tell you how much it had to actually copy. And if it wasn't 0, then you know that there were some blocks that had to be recopied and there was some corruption.
And with that said, I would not use rsync checksum to do this, to audit that. It's not really something that I would go for because it will take significantly longer in my experience, and it will mean significantly more storage load and compute load. So where I would use something like that, honestly, is if I was trying to research something. Like if I wanted to know, have I experienced bit rot, just to kind of get an idea of how frequently it occurs, then I might do something like that. But if your only concern is your actual data, just blow it away and do a clean rsync every now and then.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or your feedback. You can find me at joelrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Alan Jude.
We'll see you next week.